This is part of a new project, which is about the metaphysical consequences of the open system view. I'm going to talk about a bit more about what is the open system view, but this is the further step toward the metaphysical consequences of this view. So let me start with the motivation. Well, I mean, as you sure know, in modeling physical systems, they may be modeled as closed or open systems. It depends on pragmatic reasons, depends on the target system, depends on the interaction that we are going to take into account. So this is just standard, in a standard way. When we think of closed system, we are going to take into account mainly, this is not an exhaustive list, but just some ideas, is, well, we are mainly thinking of systems in which there are only conservative interactions with the environment or with another system. Also, in general, thinking of systems in which the energy is conserved. In the quantum case, coherence is also conserved. And in general, we are thinking of idealized systems, right? We make a lot of abstractions and we try to isolate the system and to describe the physics of this system, right? And then we call it a closed system. The strict definition of what is a closed system depends on the theory, right? It's not the same in thermodynamics, it's not the same in classical statistical mechanics, and so on. But in general, this is the idea, right? Imagine that it's an idealized thermo, right? I mean, whatever is the physics within the thermo is an idealized system. It's a closed system. Open systems, well, in general, now we are thinking of systems in which the interactions are non-conservative. There are some, for instance, dissipation, there are some friction, some damping, etc., dragging forces. There is some interchange of energy and matter with the environment, also the coherence, and someone could say something like, well, this looks like more realistic system in the sense that, well, okay, we are dealing all the time with open systems, not with closed systems. Of course, distinguishing between closed and open systems has been extremely useful, heuristically, methodologically, epistemically. There is no doubt about it. The problem is that it seems to be an ontological leap. This is what I call what is really going on in this discussion and why it's metaphysically important. Let me quote Craig's calendars in this. He's discussing with Hutchinson about time reversal in classical mechanics. To give you the context, Hutchinson is saying something like, okay, why people are repeating that classical mechanics is time reversal invariant? Of course it is not, because we have so many systems that are non-time reversal invariant, so why we are still repeating that is time reversal invariant. And he's, for instance, thinking of springs in which there is some dissipation of energy, this sort of thing. Say, okay, this is non-time reversal invariant. Why people insist on that? And Craig replied saying the following: we disregard phenomenal forces and focus on the fundamental ones when we decide whether a theory or a system it describes are time reversal invariant. When asking if the universe is time reversal invariant, we desire to know whether it is at bottom time reversal invariant. Then we make an ontological assumption. Classically, there are really only particles in motion and interparticular distance dependent forces. That is to say, as Feynman does, they are non-conservative forces. So what is the argument that Craig is pushing here? He's saying, look, of course there are many open systems that are non-time reversal invariant, but they are not metaphysically important, because fundamentally what we have is closed systems. And if you look through the literature, mainly the philosophical and metaphysical literatures about problems around time, space, what is the fundamental ontology, natural properties, and so on, you see that, okay, this focus on, okay, let's take into consideration, or let's take as relevant closed systems, or assume that closed systems are more fundamental than open systems. Again, not only methodologically, not only epistemically, but also metaphysically. This is the context. Now, in 2024, appeared this paper by Michael Cufaro and Stefan Harmont, and they pushed this open system view. It's a long paper. It's a very nice paper. It's very rich about the theory that they are trying to present here. But I mean, the main message for me in this presentation is that they make some of similar diagnosis as I have been doing before. It says, look, there's something like a closed system view, right? And the closed system view says, okay, the physics is about closed systems. The fundamental physics is about closed systems. The fundamental equation of the theories are about closed systems. And then we reconstruct open system from the dynamics of closed systems. So there's this intuition that open systems are kind of derivative, right? It's not that we really start with open systems. We start with closed, and then we build things up. And they say, but we can start the other way around. We can formulate a physics that is mainly and primitively about open systems. And then we can go to closed systems by taking them as a limiting case of open systems. So open systems are really fundamental. Physics should be about open systems, and then closed systems are going to be idealized systems of things that we take as a limiting case. They have many definitions about what they mean by a view, etc. So maybe they say this is not just something pragmatic. It's not something that, okay, we do this because it's more convenient. This is expressing a view. A view includes deep methodological and ontological assumptions about the relation between these two sort of systems. And the main claim, or I'm going to take this as the main claim that they made, is open systems are ontologically, metaphysically more fundamental than closed systems. Open system, yeah. This is what can be the open system view. So, what is going to be my thesis here? I'm going to assume the open system view, right? They present it, they defend it, but they don't say much about the consequences of assuming the view. I'm going to assume the view. I'm going to now look at the discussion about the metaphysical status of symmetries in physical theories, right? Now so I am going to assume that open systems are more fundamental than closed systems. Then I'm going to see the debate about metaphysical status of symmetries, now assuming this view. And I'm going to defend, I'm going to suggest three theses. First, maybe the open system view gives some arguments, or suggests that epistemic approaches to symmetries are better, are to be preferred over ontic approaches. Second, now in the debate about the metaphysical status of symmetries, there is a new degree of metaphysical underdeterminacy, right? Because now we have these two views, right? I'm gonna consider this. And then this is a brief comment about, well, we should probably evaluate the metaphysical consequences of the conservation-symmetry relation, right? When we take the open system view. Okay, so content, very simple. So let me go first to the distinction and a bit deeper. Well, in this paper, Stefan and Michael, what they do is first define what they mean by a view, and they say, okay, this is, again, it's not just something that we do pragmatically, it's expressing a view. It's a view because first, there is a set of methodological assumptions for model building and theory construction, for characterizing the object, relation, and other objects. So the closed and the open system view implies this set of methodological assumptions, but also they have a metaphysical attitude toward this object, right? It's the nature of this object. Also about the relation between this object that appears in the formulation of the theory. In particular, what they say is that when we are expressing this view, we are already taking some metaphysical commitment about what we are going to take as more fundamental than the other. In particular, in terms of which is the fundamental dynamics of the theory at stake. So I'm going to resume the closed system view in these two theses. I mean, again, they go further in methodological and epistemic aspect of the view. I'm going to just preserve the ontological thesis, but I'm going to take the closed system view says something like closed systems are ontologically more fundamental than open systems. This is probably the first thesis, and the second is that open system dynamics is going to be derivative, because what is fundamental is the dynamics of closed systems, and built from the fundamental laws of closed systems, plus interactions or plus a coupling with the environment, which is going to be a perturbation of the fundamental dynamics. And we have this view that we are it's like a Nancy Cartwright spirit in the sense that we are shielding, right? It's shielding the system, describing the physics of the system, and then try to talk about the interaction with the rest, but starting from the closed system. They propose the different view. Open systems now are ontologically more fundamental than closed systems. And I say, well, okay, in this case, if we take this view, we are not going to start by the closed system dynamics. We are going to assume that the physics is about open systems, but they are primitively open, let's say literally in this way. So it's not that we are going to obtain the open system dynamics by adding some coupling or some perturbation from the environment, but we are taking as primitively open. They develop a theory in the paper, this is the general quantum theory of open systems, and they show how they start with a very general master equation with a little gradient, and then they derive as a limiting case the Schrödinger equation for closed systems. But they start saying the physics is about open systems. Then we start to show how we can recover the closed system dynamics by abstractions and idealizations. So again, this is the view. Now, what is the discussion is not about? It's not about whether open systems exist. Of course they do. In the closed and the open system they exist. I mean, the discussion is not about anything. Also, it's not about whether closed systems are useful. Of course they are. They don't deny this. The discussion is about, I mean, this is maybe my reading of this, is that about the relative fundamentality from an epistemic, methodological, and ontological perspective about the relation between closed and open systems. They are changing what is fundamental, right? And then they develop a theory that starts from the commitment that open systems are fundamental. Right? But this is the shift that they are making. So, symmetries and metaphysics. This is an extremely complicated discussion. There are many aspects to dig into, but let me just separate two different discussions that I'm gonna relate it at some point, but they should be kept separate. One relation between symmetries and metaphysics is that some people think that symmetries could be guide to metaphysics, right? This is the sort of thing that is happening in symmetry to reality inferences or symmetry to fundamental inferences, right? And in the sense that if we start from some symmetries in the theory, then through some inferential mechanism we can deduce what is fundamental interaction, what is the structure of space, what is the structure of time, etc., right? This is one way in which there's a relation between symmetries and metaphysics. This is a first discussion, but there's another discussion that for me is a bit different. It's about what is the metaphysical status of symmetries. And it's what they are. What they are fundamental structure. They are entities. Some people think that they are entities. They are properties of physical systems, or just they are rule prescribing principles of epistemic posit. Right? They are somehow related, but they are strictly different. But again, and then there are many things to say in each case, but this is not my discussion here. So I'm going to just keep these two things and keep it in mind that this is a discussion in back. So I'm going to, maybe in relation with the second view, with the second problem, one could draw this distinction between ontic approaches and epistemic approaches. Again, for me, it's much more varied. There are much more things to say, but to keep this simple again, some people believe that symmetries are ontic in the sense that they are real aspects of the world, usually taken to be properties of the world or a structure of the world, or second order laws concerning the form of the first order, right? This is a quote for Lugano. Maybe a bit stronger, some people could say that they are fundamental structures of entities, like for instance, Stephen French. This is what I call ontic approaches. But also I could include ontic approaches, people that think that symmetries are useful to explore the metaphysics, right? To draw metaphysical conclusions about the world. Epistemic approaches on the other side, they say that, well, we have symmetries in the theory, that's fine, but they are not playing a referential, right? They are not really referring to something else. They are just prescribing rules as how we should reason about certain things, about certain problems, how we describe the physics, how should build dynamical equation, for instance. But in general, they are in some sense related to knowledge, to ways in which we describe the physical world. That's why I said rule, prescribing principle, epistemic positives, and so on. So again, this discussion is much more complex, I know, but I'm gonna just show you that there are at least these two sides, and that the open system view can say something about this, right? When we see this discussion from the open system view, there are some things that we should consider. So, my first hypothesis is that maybe there's an argument for the whoever defends the epistemic view, that, well, probably the symmetries that you are talking about, that they are ontic, maybe they should be considered epistemic. So, ontic approaches, think of, for instance, people that believe that for time translation invariance in some theory, we can deduce that time is homogeneous. From space translation invariance, we should conclude that the space is homogeneous, right? These are sort of things. So we can do metaphysics from the symmetries. Or people that believe that these symmetries are structures out there doing something in the metaphysics. But now when we look at the interesting symmetries, or the most relevant symmetries, they are generally, I would say the overwhelming majority of the cases, symmetries of the closed system dynamics, right? Again, in the paper, there is an example of time translation invariance in quantum mechanics and how we can learn something about time in classical mechanics from that. But it's obvious that the time translation symmetry that we are looking at is the symmetry of the isolated Hamilton. Again, there's no external field that, for instance, depends on time. Right? We are just keeping this. I'll say, okay, that's fine. I mean, you can say, yeah, what's the problem? From the closed system view, that's okay, because closed systems are the fundamental system. If you tell me that, well, if you come up with a case in which all these important symmetries break in the open system, it's not really a problem because open systems are not really fundamental. What is fundamental for the metaphysicians are the closed systems. And then the properties of the closed system dynamics are going to be the important to do metaphysics. So, no problem. And more or less this resembles the discussion between Hutchinson and Craig before. But now suppose that we change the game and say, okay, but no, I don't believe that closed systems are fundamental. I believe that open systems are fundamental. So now I say, well, when you are saying that, for instance, such systems is time reversal invariance, why should I take metaphysical seriously? Because it's a closed, highly idealized system. I believe that open systems are now fundamental, and I can show you many cases in which time reversal invariance is violated. Maybe if you have non-conservative force or something like that, it's going to be violated. So why we should take them seriously, metaphysical seriously, if they are just idealizations or limiting cases that we take from the physics of open systems. Again, this is playing the role of the open system view defender. So this is not a strict implication, but I would say that, well, it seems that ontic approaches are based in their view thinking of closed systems, right? They are there. It's not assuming, but they are like being guided by the idea that closed systems are really what is fundamental, and we should learn from them, and then we can learn about the properties of the world by looking at the closed system, among them the symmetries. But now, if you look at the situation from the open system view, it's clearly that those symmetries cannot be so real as before. They are just part of the properties or rules that we apply to idealized systems. So maybe they should be considered epistemic. Well, okay, this is what I said again, right? Again, it's not a strict implication, but it's like well, all those symmetries that are being so interesting for you, maybe just are part of the dynamics that describe closed non-fundamental systems or idealized non-fundamental systems. Again, this could be an argument. Someone could say, okay, fair enough, but this is not an argument against the ontic view. Because the ontic view could say, well, okay, maybe we have been targeting the wrong symmetries, right? But I can be ontic about the symmetries of the open system. I can endorse the open system view, and then I can say, well, I want to be ontic, but now about the symmetries of the open system dynamics. That's perfectly fine, of course. This is something that can be done. But now for me, it's a bit tricky in the sense that, in general, the symmetries of the open system dynamics are going to be quite different from the symmetries of the closed system dynamics. So if you say, okay, I believe that such and some symmetries are fundamental, well, one thing is you're believing that from the closed system view, because you are committed to certain kind of symmetries, but now you change the view, now you're going to be committed to different symmetries, and then there is a kind of metaphysical underdeterminacy. We don't really know which are the fundamental symmetries because it depends on the view, it depends on the system, it depends on the open system of the closed system view. In the paper, there's a small comment about how can you see this when you think in the 10-fold way internal symmetries for a closed system versus the 38-fold way internal symmetries in quantum mechanics for open system, right? They are different ways to classify their symmetries, and there are different symmetries for the open system, for the open quantum system with respect to the closed quantum system. Again, it's not a way to say that the ontic view is going to be rejected, but it's a way to say, well, now there's a new degree of metaphysical underdeterminacy in the sense that whatever you believe that is out there, if you believe something like symmetries or there's some metaphysical important role, which one specifically, if you have to name them, well, it's going to depend on if you believe that closed or open systems are fundamental. Again, it's not a knockdown argument, but it's something that, okay, maybe now is the discussion a bit more complex. Now, conservation and symmetry. Okay, you know perfectly well, better than me, that there's a huge association between conservation principle and some symmetries in some formulation of theories. And this has been very, very important for many reasons. Some want to read some metaphysical conclusion about that. But I think that the introduction of the open system view could also invite us to revisit, right, this relation, or at least the metaphysical relevance of this relation. Because for some specific closed systems and some specific symmetries, it's more than continuous. If you write the theory in the Lagrangian way, it's true that you have this mutual implication between conservation principles and symmetries. But it holds only if the action doesn't involve dissipative forces. In general, when you have some dissipative force, one of the symmetries is going to be violated, and then the conservation principle is going to be violated too. Now, okay, if you are the closed system view, this is again not a real problem, because okay, it's not a real problem because you don't believe that it's open systems that breaks some specific symmetries, and then the conservation principles are not really fundamental, are not really important for doing metaphysics or drawing some philosophical conclusions. But now, when we move to the open system view, is important because now the open system, both in the quantum and the classical case, the relation between conservation principles and symmetries is much weaker. I mean, there's no easy implication. Sometimes conservation principles doesn't imply a symmetry, sometimes yes, sometimes it's the other way around, sometimes the symmetries doesn't imply the conservation, and sometimes they do. So it depends really case by case. Yeah, so what? For the closed system view, there's no problem. For the open system view, the situation changed. But it's not that the physics change. Of course, the physics is exactly the same. There's nothing about that. What the change is that by shifting what is fundamental of the system we should pay attention to, we are changing the metaphysical, philosophical importance of this relation between conservation principles and symmetries. Again, it's not the argument that they are not important. The argument is that they don't play that. If someone believes that they could play a metaphysical important role, they shouldn't play it in the open system view, because again, it's not a property, it's not a relation that holds always when we have open system, both in the quantum and the classical case, right? So, some conclusions. I haven't defended the open system view, right? I mean, if you want a defense, go to the Stefan and Michael's paper. But I have assumed that it's correct, that we should take this view, and then try to explore the consequences for this view, right? Why I did that? Because I had the intuition before that something like the closed system was very, very entrenched in our way to formulate some philosophical problems or metaphysical problems. Problems about time, problems about space, problems about fundamental interactions, blah, blah. So is it, okay, maybe we shift this view, okay, probably the consequences could be different. Maybe not, maybe yes, but I think that they're going to be different. And so in some cases, they're going to be radically different. Again, it's a conditional statement, right? If we accept the open system view, then these are going to be the consequences. Again, it's a conditional, so it's just that. Okay, in this paper presentation, I've shown these 3 points, right? I think that open system view, when we look at the discussion about the structure of symmetries, they favor epistemic approaches, changing which symmetries are metaphysically fundamental, which introduces some degree of metaphysical underdeterminacy. And this dissociation between conservation principle and symmetries that is probably important for philosophical and metaphysical discussion. So, but there are much work to do, of course, because we can, at the end of the paper, they mentioned, Stefan Harman and Michael Buchar, they mentioned that maybe we can apply this view to a range of different problems. And they don't mention symmetry, but for instance, they mention the direction of time. Say, okay, how we should reason now about, for instance, the direction of time? We think that open systems are more fundamental. And this is the discussion I mentioned before between Hutchinson and Craig's calendar, right? Probably there's something to say there. Or maybe there's something to say about the metaphysics of law. So maybe now if we think about closed system, from the open system view, probably the metaphysical law is going to be different. But also there are many other problems because it's not clear if we have symmetries to reason about the structure of space and time. So you see, it's like, I am not saying that we should endorse the open system view and draw all the consequences, but I'm saying, okay, this is an interesting starting point, and then we can see how far we can get, right? But I think that in this particular case about symmetries, well, there is some things that could be said. So, thank you very much.
We have a comment by Charlotte Zito.
Hi, thank you, Cristian. I find it very interesting. So we have seen like these 2 views, which change completely like the way we look at symmetries when we think about them. And I think one way these two views can be phrased is that, okay, we have the closed system view, which is somehow the result of some idealizations that we put in our physical models. And this view gives us one kind of ontology or metaphysics about symmetries. And then we have the open system view, which seems to me to say, okay, but what we really have in the world are not like closed systems. We only have one closed system actually, which is the whole universe. But what we really have are like open systems which constantly interact with one another. And so, like, but another, like, one thing, and they both have like some metaphysical consequences and like some advantages and maybe disadvantages on the way we see the world. But one thing that the closed system view does, as I have understood it, is that, I mean, this is the view that physicists and the majority of people have in the back of their mind when they do stuff actually. And one thing that we gain with this view is that we are actually able to explain lots of stuff about the world. And I know that you didn't want to defend the open system view, but yeah, I just wanted to ask you, like how does the open system view squares when we consider the explanatory power that we gain when we actually adopt an open system view? And related to that, maybe more in general, like what do you think about the role of approximations and idealizations when we are doing like scientific practice, or when we really do stuff and try to understand the structure of the world? Because the open system view doesn't seem to care much about idealizations, or like looks to say, well, we really have to look the world as it is, so we should like disregard about like, yeah, doing approximations or idealizations. But then, yeah, I would like to know more about like, yeah, the explanatory power and yeah, the role of idealizations in science. And then I thought about this like this morning actually after Tyler Hildebrandt's talk. So I don't know whether this makes much sense, but it seems to me that these two metaphysical views might, like, they for sure have different goals and they have different purposes when thinking about the world. So, and they also have like so different motivations. So you talk about the motivations in general for like distinguishing the two views. So we gain like different metaphysical views of like, the structure of the world. But maybe, yeah, just saying a little bit more about the motivations for this, like each view taken on their own, and whether, since they both might have some goals and like maybe they might weight different stuff in different ways, whether you think that this brings us toward a more agnostic view about like the role of metaphysics. But yeah, maybe there is more to say about this. And then I just wanted you to say a little bit more about the arrow that you had on slide 4 about because you said, okay, the difference between like the open system view and the closed system view is basically, yeah, the arrow that goes from closed system to open systems and vice versa. And I just wanted you to say a little bit more about this notion of relative fundamentality between like the open system and the closed system, because we said that like the closed system are like recovered as like as a limit case. So yeah, I just wanted to say a little bit more about that power and what is implied, and how do we recover a closed system from open systems.
Okay, great. Okay, thank you very much. Probably you're going to have to remember me some of the questions, but let me start just. you say about idealizations, whether they care or not about idealizations. And at least for me, this was why I say, well, maybe the open system view is interesting, because of course they care very much about idealization. They say, of course we should do it, and they show in this general quantum mechanics of open systems how they can obtain the Schrodinger equation for the Schrodinger equation for a closed system from the master equation from open system by a limiting case idealization. So they care about what I found interesting, that they place idealizations as a instrument to obtain something else. And my intuition was that, well, in general, it's hard. They are starting from the open system, and then they idealize and show that, well, these systems that are not the fundamental, are not the system you start with, they can obtain by idealization. So the idealization is clear in the theory that plays just an instrumental role for obtaining something else. But when you start the other way around, maybe it's not so clear that you start with an idealization and the closed system is an idealization. You can find many ways to justify that, but at least at the level of how to present the theory, it's clear that idealizations are instruments. In the other view, it's not so clear sometimes. Then I go on to the second question: what is this appeal? Is that if you have a view, like this is something I haven't thought very much about it, but if you have a view close to Nancy Cartwright's view, right? Well, okay, you have these laws, but they are schema of law, they are shielded theory. What's really happening is, you know, the dispositional nature of things, so everything is. If you have this view in mind, well, it's a motivation to view or try to endorse something like the open system view, in which you really very clearly see that the closed system view, that the closed system's dynamics is a limiting case of something that is more real or fundamental, right? Again, it's about how you present the theory. I mean, I have talked about with Stefan, because in this paper they develop a theory in which they present a new, the structure of the theory, the general quantum theory for open systems. So you say, okay, for all the cases we should develop a new theory or not? Say, well, not always, but it's a very nice way to present how the theory shows you what is the right place of the things, right? What is the right place of open system, because you start with them, so you show clearly that they are the target of physics, and then you show that closed systems and idealizations are secondary in the sense that they are obtained by some techniques, but they are not really. So I think that this is two things. Now, what they explain, I mean, in the sense they're just developing an alternative theory. They explain, of course, if you look at the scientific explanation, it's going to be the same, because what they develop is just a different way to derive the equation, to present the equation, which when you start with a Schrodinger equation, you start with a Litt-Blattman equation. But I think that if you move to the metaphysical view, is again, if you have an intuition that, well, what there really is not closed system, but something like open system, Nancy Cartwright's type philosophy, well, you have an explanation how the physics is not contradicting that, right? It's not that showing that there are some idealized laws that govern somehow. No, I mean, you have the open system, you have the physics, and then you derive the rest. So in that sense, I would say that they are scientifically explanatory is the same, but metaphysically maybe it's appealing for people that have this view, right? Of course, if you don't believe in that, well, okay, probably you're not going to find so much explanatory. About the arrow, is probably is what I already said, but I'm just going to repeat it briefly, is that it's just how you start presenting the theory, right? And say, well, usually when you have the closed system view, you start with to formulate, you say the target of physics is to model this system, the free particle, suppose. And then we give the physics for these systems. And then we discover, well, because we already knew it, but we say, okay, but now we have to take into account interaction, because this system could be open and could be interacting with other things. And then we derive, or we add some disturbance and some coupling with the environment, and then we try to model the open system. But we start with the closed system, and then you have this idea that open system comes after the closed system, right? They start, well, the other way, if you read the paper, they start saying, okay, this is the master equation for an open system, and it's primitively open. And then we are going to be try to show how we can isolate the system, and when you have the maximum isolation, then you show that the equation that we describe this closed system, starting from the open system, is something like the Schrödinger equation. And then that's why the closed system is derived from the open system, right? Again, this is just matter of how you present the theory, but they also give that, okay, this is a clear way. It's a clear way to show how the ontology also goes, right? How the ontology goes from open system to closed system, because these are more fundamental, the first one is fundamental. I don't remember the first question, if you can.
But I think we covered maybe just like saying a little bit more about like the motivation for like each view, but I think we covered pretty much all the time.
Okay. Yeah, I think that the motivation are a bit of philosophical guts in some way. It says, if you don't find comfortable with endorsing idealization or taking idealization too metaphysically seriously, well, maybe you have a motivation to find a framework in which it's very clear that idealization plays some accessory role. I'm not saying that the other system, the other view cannot say that, but it's not so clear. Again, when you have these discussions again about Fresnel symmetries, all this kind of, I found the correct calendar reaction very natural, in the sense that what you are saying, of course, these systems are not important. We don't care about a spring that have some friction. We don't care about that. We care about the idealized undampened harmonic oscillator, for instance. So again, if you feel that, okay, this reply is not very satisfactory, because why we should read so much from idealized systems, well, it could be a motivation to look at this open system view. But of course, the motivation counter is that maybe the open system view could imply things that we don't like. We don't like, some things could be, could be a bit worrisome. But I mean, we can talk about that later. Yeah, thank you very much for your question.
All right, so a bit of time for questions. Go ahead. Okay.
Yeah, thank you very much. So I'm new to this, and it was very illuminating. So this may be kind of a naive clerical question. So for some reason, when I was introduced to the open system view, I was just reminded me of ironically, the very default analytic metaphysicians like thoughts about fundamentality, which often goes fundamentality. That's going to require, that's going to imply reality. Reality implies truth in the world, whatever that means. So I was thinking that maybe somewhat ironically, maybe following the default analytic metaphysicians view, which kind of maybe that might be ground theorists or Ted Sider, they say that they might actually think that, oh, the open system view might be the right way in terms of anti-fundamentality. Yeah, I just do you think this way of interpretation is right, or does this kind of bother you? I don't know. Yeah.
I'm not sure. In the sense that, again, I think that the motivations for endorsing either view are not quite related to fundamentality itself. I mean, fundamentality is just it's the place in which you say, okay, I'm going to consider fundamental these things, or I'm going to consider fundamental these other things. For me, a lot of good metaphysics has been done by filling fundamentality with closed systems, right? And then, because I mean, it's usually probably easier, I don't know. But the discussion is not about this fundamentality thing, it's about the content itself. And the content is could be motivated by what I said before, is that, well, when you're filling the fundamental things with things that look too much idealized, when you can have some worries. And if you have those worries, you can say, well, maybe I want to fill it with something else. For me, I mean, again, this is not something I have thought about it so much, but I find that sometimes you have a inclination for dispositionalist view, this feeling that powers or dispositions are fundamental. Well, then maybe you can say, okay, maybe what you have fundamentally are something like open system, because dispositions are always fundamental. So, well, maybe you have a motivation to endorse the view, but it comes from your previous metaphysical assumption about from out of nothing. I don't know. I mean, if you have any more motivation, I should ask Stefan or Michael what's the motivation to developing this view. But I think this intuition that the target of physics shouldn't be closed system, should be open system, and it should be very clear about that. And then we formulate a theory and a view that show that. Just, I don't know if I replied to your question. Okay.
Yeah, I think you may have to be a bit more committal on how you are thinking of fundamentality. So I take it that the universe is closed. And so if you're a priority monist at a Scheffer, then the world is prior, and therefore there is just one fundamental thing which is closed, so you have in mind trivial and false.
Yeah.
So yeah, I mean,
yeah.
I'm not saying that you should do it now, but you know.
No, yeah, but that's a very good point. It's true that if you believe something like Schaffer, and you believe that the universe is the most fundamental thing, then you have an argument to say that all systems are fundamental because in principle it's closed. But two things. In general, when we think about symmetries in this case, we are not really thinking about symmetries of the whole universe, right? We are thinking of symmetries of subsystems. So if we want to move out the symmetries of the whole universe, then we shouldn't care about the discussion. We should look at GR and the symmetries in each particular model, and this is a different discussion. So in this case, I am not talking about the entire universe. Probably it's a restriction of the view, or maybe not, depends. So I'm not taking into account this view because this is not the symmetry that I am interested in here. But this is one point, but you are right, that could be a metaphysical view that block this idea, but then I would press that, well, there are many discussions then that doesn't make sense in this area. For instance, this discussion about symmetries, I don't know, we should just look at GR and the symmetries of each model. So everything was irrelevant in this sense. But there is a paper, it's not published yet. There is a paper by Sean Greaves and David Sloan that is, I think it's in the archive, and they explore different meanings of what is open system, right? And they give an argument to say that one way in which we can think of open systems is about in terms of a dynamics that is autonomous. And they argue that when you look at the description of the universe, you don't have this dynamics. So in some sense, the dynamics of the universe, of the description of the universe, is not autonomous. Therefore, it's not really closed. It's not published yet, but it could be some way to discuss it. But I take your first point that more about what is fundamental should be said, and I agree that there are some views that can say it is a non-starter because I believe that the universe is the only thing. So this is fair enough. Yeah.
Finger?
Yeah, but I have a finger, but I think you have a finger before I did. So
You said most of what I would say.
no, it's just a very small thing. I am fairly sure that Kufarov and Hartman speak about Schaffer priority. So
Okay.
Yeah.
I should look at that.
Yeah.
I should.
In that paper, but
Yeah.
They seem to think it's not relevant because they seem to think that like being a closed system
being an open system isn't the same as having an external environment. So
Yeah.
even the entire universe is still actually an open system, and we just like break the conceptual connection between being open and having a separate environment. It's really hard to understand what an open system is then. It's something like it's a system that is properly characterized by the kind of equation you would use if there was an environment. So it's kind of, it's a bit,
Yeah,
it's a bit weird.
Yeah.
Very. Yes, sir.
Yeah, no, it's probably clarification of this, but could you, I suppose this is a sort of area that's ripe for like scientifically informed metaphysics, right? It feels like science should be giving a name, informing of the issues here. And so that makes me wonder if your argument might lead to something like a reductio or an argument against the open systems view, because if you're right that you've got this weakening link between conservation laws and symmetries, and if the scientists think that we don't want to do that because maybe the Noether's theorem thing is quite revered and quite important, well then that could be used to kind of... Is that something that someone might do, or am I misunderstanding the kind of dialogue?
Yeah, I mean, this is, I mean, of course, in both, in open system views and the closed system view, the physics is going to be exactly the same. So you're going to have the conservation principles on both, you're going to have the Noether theorems, and everything is going to be exactly the same. Now, so for the physics, it's nothing, it's just exactly the same.
Yeah.
Now, when the proposal is, okay, now we have everything here, we have the physics, now what we should give more importance, closed systems or open systems. And then, when we explore the properties of the system, we are going to find different things. And then we are going to take these different things metaphysically more seriously or less seriously, depending on the place that we are seeing. So in this case, yeah, we're going to say that, okay, conservation principles are not there. Of course, they are there in the theory, but they are not so important because they are properties of the closed system. So metaphysically, it's not that physics is going to teach us what is going to be the metaphysics. It's the assumption that these systems are fundamental, which trigger the inferential mechanism to draw metaphysical conclusion. And this is what the open system uses from Bloch. He said, we cannot draw this conclusion because now we are not assuming that these systems are metaphysically important, metaphysically deflated in some way. So I would say that it wouldn't be an argument against, because it's not going against the physics. It's going against the place that some philosophers and metaphysicians have given to the closed system, thereby to the conservation principle. Right? Could be, and I think I would phrase the discussion in this way.
Any other question? Isn't I had one. So I've been trying to think a bit about the metaphysics of open systems, context of interdigital black hole, but anyway, and I was wondering, what do you think about the idea of trying to use some of the resources from the eliminativist literature, the metaphysics of objects, to try to clarify a bit the oceans on the table? Are you able to say something like, well, closed systems look like idealization, just like imagine that being a naive realist about objects around us, like an idealization, and in fact we should think that ordinary objects don't really exist, and projections into reality where we basically put some we project some perimeters of the past of reality. I mean, do you think it might be useful, or do you think it's really disconnected from the kind of things you're doing?
I would say that the direction is the other way around. I mean, I think that at least my motivation, I think in part is also Stefan's motivation, is that at some point we want to see that ordinary objects are not real. It's the opposite, to show that physics, the fundamental physics, the fundamental formulation of a theory, is closer to the ordinary object in some way, right? If I have to be eliminativist about something, it would be about the closed system, not about the open system. We'll say, if you push me further, I would say, I would be eliminativist about. I would take it as part of theoretical resources that you have to deploy for formulating a theory, for etc., but they are not really referring to something. Yeah, I would go that way. I mean, I haven't given the argument here, but I would go that way. Right. The same thing with symmetries. I would go to the epistemic view.
All right. Okay. Then please join me to thank Cristian
Thank you
again.
very much.